Okay, YouTube, in this video we're going to focus on how to simplify radical expressions containing, say, negative radicans when we have an even index out here. So most specifically square roots, but how we simplify things in terms of I and how we don't simplify things in terms of I. So let's go ahead and start by talking about the principal square root of a negative number. Whenever we take the square root of a negative number, say for instance here we have this negative b, we can rewrite this as I times root b, where this b has just now become positive just by sticking the I out front. And this is just simply because we could use our product property that says, well, negative b is the same thing as negative 1 times b, which is the same thing as the square root of negative 1 times the square root of positive b, which comes out to be I times root b, which, because we use the shortcut I to denote the square root of negative 1, we could basically say you just take the I out front and we'll make this radicand positive. That being said, the important note that we want to make here in this video here is essentially this. When rewriting radicals, let's say square roots specifically, negatives, always rewrite in terms of the imaginary unit I first. And that's important because you'll see a couple of examples I want to go through down here that are already worked out, but kind of a correct way to do things and an incorrect way to do things. And sometimes you get people doing the incorrect way, and we don't want them to do that. So taking a look at this expression here, we have the square root of negative 25 and the square root of negative 4. And the correct way to do this would be to do exactly the thing that I just wrote right here, which is rewrite it in terms of the imaginary unit I first using this principal square root of negatives property. So basically, the square root of negative 25 times the square root of negative 4, the first thing we would do is to just put i's out in front of both of these. And we always list the I in front so we don't confuse it as maybe being inside the radicand, but we would say I times the square root of positive 25 and I times the square root of positive 4. And then we could simplify these because, well, we know the square root of 25 is 5 and square root of 4 is 2. We would get 5i times 2i, which gives us a 10i squared. And knowing what we know about I squared, since I is really equal to the square root of negative 1, then I squared, recall, is equal to negative 1, or the square root of negative 1 squared. So really, this 10i squared just becomes a negative 10, or the opposite of this initial value out in front. So the wrong way to do things, though, the way we want to avoid is this. We have this product property that says the square root of a times the square root of b can also be rewritten as the square root of a times b, where we combine the stuff on the inside. And if we do not write this in terms of I first, then what you get is the square root of negative 25 times a negative 4, which of course is a positive 100. And we say the square root of 100 is 10. You notice the difference here. We need negative 10. We wanted a number that when you square it, you get a negative output. We get some negative outputs here, and here we're not getting that, okay? So always rewrite in terms of I first. So I've just got 3 examples here that I'm going to kind of run through and talk about how we would rewrite these first. So looking at this first expression, we have 2 unlike radicals that we're going to simplify, and the first thing we'll do is we'll put an I out in front of this 27 here, this root 27, and make it positive. And we say this would be I times the square root of positive 48. So simplifying these, I know that 27, 9 is a perfect square, and that certainly is a factor of 27. So I get 9 times 2, plus now I times the square root of, now what goes into this? I can think of 16 as a perfect square, it goes into that 3 times. What we're going to end up with here is this. We would get I times 3 times root 2. Oh, whoa, that's a 3. 9 times 3 is 27, pardon me. But we would take out the 3 for this 9 here, and the 3 would be left inside. And then we would say here, reducing this 16, we would get a 4 out front. So we get I times that 4 times root 3. In other words, we should write this as 3i root 3 plus 4i root 3. And because these are like radicals, we could say, well, how many root 3's do we have? Well, we have 3i plus 4i of those radicals. So we have 7i root 3's, and that would be our simplified form. Looking at this next one here, you notice that we have this binomial squared where we have negative 2 plus the square root of negative 3, all of this squared. So we're not going to square its individual parts. That's algebraically unsound. We need to take it times itself, but the first thing we're going to do is rewrite this root of a negative. Square root of a negative as I times the square root of the positive radicand in there, squared. So what we'll get is this situation where now we're going to have to FOIL. So we get I root 3, okay, and negative 2 plus I root 3. So foiling this out, we would get negative 2 times negative 2. Well, that's going to give us 4. And then I get negative 2i root 3 and another negative 2i root 3. So I have negative 4i root 3. And then if I take I root 3 times I root 3, I'm going to get a positive, in this case, I squared. square root of 3 squared. So simplifying this now, we have 4 minus 4I root 3. The I squared here is a negative 1. And also, the other thing we want to mention here is the square root of 3 squared is a 3. So this actually becomes a negative 3 right here. And when we combine that negative 3 with this positive 4 right here, we're just going to get a positive 1. So we get 1 minus 4I root 3. And sometimes you'll see this is written as 1 minus 4 root 3 and I off on the side. But this would be our complex number in standard form here. I'd prefer that we write it this way. Now lastly, this one here. Again, we're going to rewrite this in terms of I before we do anything. So we'd have negative 14 plus I times the square root of positive 12 now, all over 2. And we could also reduce this radical over here. We know that 4 is a factor of 12, and it's a perfect square. So rewriting this, we could say, well, that 4 will take the 2 out front. And so now we have this expression, 14 plus 2I root 3 all over 2. So now, whenever you have a rational expression like this, the best thing to do is always simplify it if possible by factoring the top and bottom. And I notice that the top and bottom, well, at least the top, right now has a common factor of 2. So I'm going to factor out a 2. I'm going to say this is 2 times negative 7 plus just an I root 3. And this is all over 2. And the reason why is because we can reduce this by a factor of 2. And our final expression would just be negative 7 plus I root 3. So remember, always rewrite things in terms of I prior to doing any simplifications or calculations. Cheers.